Hey guys, okay, so today I want to talk about solving rational equations. And what we have to make sure of is when we solve that we are checking our answers because we may produce an extraneous solution. So let's talk about an extraneous solution, okay? So it's a solution of an equation that's derived from an original equation that is not a solution to the original equation. So these examples are my original equation. Now, when we solve, we want to make it easy for ourselves. And not a lot of people like to solve equations with fractions. So the fastest way to get rid of a fraction when you're solving is to actually multiply the entire equation by whatever you see in your denominator, okay? So if these were all fractions, x over 1, 6 over 1, really the only thing in my denominator is that x. So I'm going to multiply the entire equation by x. And I want you to go term by term. So the first term, x times x, is x squared. 8 over x times x, well, this is a numerator, that's a denominator, so they cancel each other out, and it just leaves 8. And then 6 times x is 6x. So this is called a derived equation, okay? It's not my original. I made it simpler for myself by multiplying the entire equation by x. So this is my derived. So I'm going to go ahead and solve my derived equation, but I always have to check with what my x values are back to my original to see if they also solve the original. So whenever you see an x squared, I want you to think, oh, I have to move everything to one side to solve, okay? When you see x squared, you can solve by factoring, you can solve by quadratic formula, or completing the square. This one, we can factor, okay? Factors of 8 that add to get 6 would be 4 and 2. They both have to be negative because they're adding to get a negative, and they're multiplying to get a positive. Okay, if we set those equal to 0, x is 4 and x is 2. Okay, so we have to check. If I put a 4 in my x's, 4 plus 8 over 4, well, 8 divided by 4 is 2. So 4 plus 2 equals 6. Yeah, 4 plus 2 is 6. So I know 4 is a solution. Okay, if I plug in a 2, 2 plus 8 divided by 2 is 4. So 2 plus 4 is 6 equals 6. That is also a solution. Okay. Now, we're going to do the same concept. So our problems are going to get larger. So for this one, I'm going to multiply the entire equation by what I see in my denominators. I see a 2 and I see an x minus 7. So I'm not going to combine those. I'm not going to distribute the 2. I'm going to leave them separate out here, and we are multiplying. So when we look at our first term, okay, my x minus 7s cancel, and it leaves 2 outside times 2x minus 9. So I have 2 times 2x minus 9. For the second term, my 2's cancel, and it leaves me x times x minus 7. So x times x minus 7. My third term, my x minus 7's cancel, and it leaves me 5 times 2, which is 10. Okay, so remember, before we can add, subtract, or combine like terms, we have to multiply. So I'm going to distribute the 2. This is 4x minus 18. This is x squared minus 7x equals 10. I'm going to combine everything to one side. I have my x squared, then I have a negative 7x and a 4x, so that's a negative 3x. Then I have a negative 18, and if I remove this positive 10 over, it's going to become negative 10. So it's going to be a negative 28. Okay, this one I can factor. Factors of 28 that add to get 3, 7 and 4. A negative 3, so my negative 7. Positive 4. So x equals 7, x equals negative 4. Check. Go back to your original and plug it in. Now, to save time for everybody, look at your denominator first. If I plug in a 7, 7 minus 7 is 0. And in algebra, we never want 0 in our denominator. It would be undefined. So right away, I know that's extraneous. Which, it's an answer to my derived equation, but not to the original equation. If I plugged in the -4, you're literally going to plug in a -4 every single place you see the x. Okay? That will be -4 equals -4. And you can use a calculator. So this is my solution to that problem, not the 7. All right, good luck, guys.